Hello, hello, here is your quick tutorial on circular motion. So circular motion, or uniform circular motion, is experienced by an object when it moves in a circle at a constant speed. So that's the key for uniform circular motion, is that we have a constant speed. The magnitude of velocity is constant, while the direction of the velocity vector changes. So the velocity vectors are tangent to the circle, like in this picture here. So again, speed is going to stay the same, but velocity is going to change because our direction is changing. Okay, and velocity, again, a velocity vector for something moving in a circle is going to be tangent to that circle. Now we also have centripetal acceleration. Since the direction of velocity is changing, there is acceleration. So again, when we have changing velocity, we have acceleration. So even though the magnitude of the velocity is not changing, because we have a change in direction, we are going to have acceleration. So centripetal acceleration is center pointing and is given by this equation. A sub c is equal to v squared over r. So A sub c is your centripetal acceleration. And in your book, Giancoli, they use A sub r instead of A sub a, or A sub c, but it is the same thing. V squared is your velocity squared, and r is the radius of your circle. So you can see here we have these velocity vectors drawn tangent to the circle. But if you look at the acceleration vector points inward. It is center seeking. Some other terms to note, and we'll do more with this when we get to waves, is frequency and period. So the frequency, f, of an object in circular motion is the number of revolutions per second, while the period, capital T, of an object revolving in a circle is the time required to complete one revolution. So these two have an inverse relationship or a reciprocal relationship. So T, or the period, is equal to 1 over the frequency. You could also say that frequency is equal to 1 over the period. So they have an inverse relationship. Frequency is given in inverse seconds or hertz. Period is given in seconds. We also have another formula that we can use for velocity. Since velocity is distance over time or displacement over time, the distance traveled in one full rotation of a circle is the circumference. And circumference is given by the equation 2 pi r. So the time it takes to travel one full rotation is the period, t. And that gives you the equation for velocity, v equals 2 pi r over t. Again, 2 pi r is equivalent to your displacement, and t is your period. Be careful that you're not thinking about displacement as in like you started at one point in the circle and then you're going all the way back to the same point. That's why we're using period instead of time, because period would be the amount of time it takes you to go that one full circle. Okay, so we're using 2 pi r over the period. We have this example. A plane makes a complete circle with radius of 3,622 meters in 2.1 minutes. What is the speed of the plane? So using v equals 2 pi r over the period, we have 2 pi times 3,622, and then divided by 2.1 minutes. We can't use 2.1 minutes though, because our units should always be in seconds, not minutes. So if we convert this to seconds by multiplying by 60, we have 126. So your final answer for the velocity of this plane should be 181 meters per second. Using that new relationship that we found for velocity, we have another equation for centripetal acceleration. So this equation is a sub c is equal to 4 pi squared r divided by the period squared. So make sure that you square your pi, okay? Be careful with that. And let's remember that centripetal means center seeking. So the centripetal or radial acceleration is always pointed toward the center of the circle. It is not pointed outward, it is pointed toward the center of the circle. All right, next time we're going to talk about circular motion dynamics.